Hello, so this is quite a wordy question, but if you just break it down, if you understand the chain rule, you'll get it. Okay, so a container in the shape of an inverted cone. I haven't actually got any images on here, so I'm going to draw an image down so I can actually see what's going on. So I've got a container in the shape of an inverted cone. Let's draw that a little bit better. There we go. An inverted cone has a radius of 3 meters, so I'm just going to draw that radius in there. That's got 3 meters there, and a vertical height, so let's draw that vertical height in there, of 4.5 meters, okay? And it's initially filled with liquid fertilizer. So if you can imagine, that's initially filled all the way to the top with liquid fertilizer. I'm then told that this fertilizer released through a hole in the bottom of the container. So if you can imagine, there's a little hole in the bottom of the container, and the liquid fertilizer is basically dripping out of that and it's kind of forming a puddle somewhere, at a rate of 0.1 meters cubed per second. Now just stop a minute. What does rate mean? Rate should be screaming out at you with these types of questions, because rate literally means differentiate. Okay, so differentiate literally measures the rate at which something happens. So it's usually the rate of change. Okay, so the rate just means how quickly something's happening, and how quickly is it happening? Well, it's happening at 0.01. But what's it actually measuring? What is changing at 0.01? Well, if you look at the unit, that will tell you. Okay, so it's meters cubed. That's volume. Okay, so in other words, I know that dV, okay, and rate is always measured with respect to time, but if you weren't sure about that, you've always got the seconds there to kind of guide you, show it's with respect to time, is 0.01. Now, you've got to think sometimes about what's actually going on here with these types of questions, okay? It's decreasing, would you be happy? The fertilizer in there, as it's being dripped out, would you be happy that the height of the fertilizer, so how much fertilizer is left, is kind of decreasing? It's going down by 0.01 meters cubed per second. So if it's going down, therefore, I'm taking away 0.01 from my initial value, okay? So it has to be going down by a negative amount. If it was growing, if it was increasing, I'd be adding it, so therefore it would be a positive there. So basically, that sign at the front there tells you how it's changing, whether it's increasing, positive, or decreasing, in this case, which is negative, okay? So I know dV by dt is negative 0.01. I'm then told that at time t seconds, the fertilizer remaining in the container forms an inverted cone. So I've got an inverted cone left. That kind of makes sense, because as the fertilizer kind of goes down, then I'm going to have less and less fertilizer in the container. Okay, so that's kind of got less fertilizer in there. Okay, and it's forming an inverted cone of height h meters. I don't know what that is. So if I just draw that little inverted cone out again, okay, so a little inverted cone out again, something like that. Okay, that's still got height, which I don't know, but it's h meters. And it's also still got a radius. Would you be happy? That radius, I don't know, so I'm just going to call it r. Okay, I'm just going to call that r meters. Okay, so that radius I don't know, it's just r meters. Okay, fine. Now, show that is that, okay? So effectively what I'm being asked there, I mean, I actually think they've made the question a little bit more tricky, because they've asked kind of something a bit weird. But basically, they're asking you to find dH by dt. As soon as you see something which you don't currently have, I don't have a dH by dt, it means try and find that and then try and manipulate it to show it's equal to that whole thing. Okay, so basically, I need dH by dt. This is just a connected rates of change question. What it literally means is it's saying, how is that connected to something I already know? So how is the height changing? Well, the height is obviously going to be connected to something else. It's going to be connected to something like the radius, or it's going to be connected to something like the volume. Okay, and actually in this case, I've got dV by dt. So when I ask these questions, okay, I say, right, what do I need? I need dH by dt. What have I got? I've got dV by dt. How are they connected? So what do I need? Okay, what do I need to find in order to find dH by dt? Well, think it's just a chain rule, okay? So remember, these two things are connected. So the height of the liquid left in the container is going to be obviously connected to the volume, because they're obviously going to be decreasing. How are they connected? They're connected by the chain rule. Okay. So what do I need? Well, look here. I want dH by dt. So whatever I have on the right hand side, there's going to be another fraction at the front here, and whatever I have on the right hand side, that basically needs to cancel effectively, just to be left with dH by dt. So look, I need a dH, okay, and I haven't got a dH currently, so I'm going to put a dH here, okay, and at the moment I've got a dH here, I've got dt here, but I haven't got a dV on this side, so I need to get rid of that dV, and remember, whatever goes here and here, they just cancel, and it's as if the dVs were never there. Okay, so basically, what do I need to find? I need to find dH by dV. Now, with these types of questions, there's nearly always a standard formula, like an area formula or a volume formula that will connect it. And actually, they've very helpfully given us a formula that we can use. So we've got V equals a third pi r squared h. Now, this is a little bit awkward, because some of you might just jump in and say, well, that is just the flipped version of dV by dH. That's just dv by dh flipped, basically. So if I can find dv by dh, then I can find dh by dv. You say, oh, okay, I've got a v there, I've got an h there, so therefore I can just differentiate that and just be left with 1/3 pi r squared. No, because if you look, I've also got an r going on there. And if you have a look at this kind of situation, fairly obviously the radius of this cone is also going to change as the volume decreases. So actually, I've got 3 variables going on there. So I can't just differentiate one variable with respect to the other and kind of get what's called an ordinary derivative, so it's just 2 variables going on. I can only do a partial derivative. Don't worry about that. But basically, because I've got an r going on, that screws things up. So what I need to try and do is I need to try and do something with this formula to get rid of that r. So can I replace that r with something? Well, look over here. Look over here. This is your key. Okay. Would you be happy that I've got basically 2 similar shapes? I've got a smaller cone and I've got a bigger cone. Okay. And I know that I've got a radius and a height of both of those cones. So because they're similar shapes, go back to GCSE, I can write the 2 things as ratios of each other. So I can write, for example, the radius of the new shape over the height of the new shape should just be equal to some scale factor times, so it should just be equal to the ratio of the 3, so the radius of the old shape, over the height of the old shape, so 4.5. So basically the ratios are still the same. Like this, if this was like 2 times this thing, then fairly obviously, you know, I'll just have this thing will come out as 2 and this thing will come out as 2, because basically the ratios are still the same. If you're not sure about that, think about scale factors. So I just multiply a scale factor by this old shape to get the new shape, and then I can obviously rearrange that and you'll end up exactly the same place. But the point is I can now just rearrange this to just get r equals on its own. So r is just going to be equal to, well, I just multiply 3 by h. So I've got 3 over 4.5 times h. What's 3 over 4.5? Well, I can see that 1.5 goes into both of them. So actually, if you put it into a calculator as well, this just comes out as 2/3. So now I can just replace r with 2/3 times h. And that's totally okay, because now I'm just left with stuff involving h. Okay, so I'll just replace r with 2/3 times h. Just be careful. Just be careful that you're squaring it. Okay, so it's 2/3 times h. So it's 2/3 times h all squared. Okay, so let's just expand this out just a little bit. So let's get rid of this. Okay, so this is just equal to 1/3. Just equal to 1/3 pi. 2/3 squared. Square the top, square the bottom. So that becomes 4/9. 4/9. H becomes h squared, okay? H squared, but then I'm timesing by h at the end as well, so I've got an h there. So I'm just going to become h cubed, okay? Let's combine these 2 fractions together. So what's 1/3 times 4/9? That's going to be 4/27, isn't it? So 4/27 times h cubed. That's v. And if you notice now, I've just got v solely in terms of h, which means I can differentiate it. I mean, sure, I've got this 4/27 pi there, but that's just like a number. That's just like a 2 or 3 or 5. It's just a number. It's not going to affect the differentiation. So what then? Question is now then, what is dv by dh? Okay, so the 4/27 pi is not going to affect it. It's a horrible number, but doesn't going to affect it. So basically, what is just the derivative of h cubed? It's just going to be 3h squared. Okay, and actually I can probably cancel that 3 with that 27 and just be left with 4/9 as well. Okay, you see what I've just done there? So 4/27, 4/9 times pi h is dv by dh, and then I can just sub that in to this equation up here. So, I know then that dh by dt, the thing which I want to find, is just going to be equal to dh by dv, which is just a flipped version of that, because that's dv by dh, I want dh by dv, I just flip it, okay? So dh by dv is just going to be the flipped version of that. I'm actually going to stick that all over 9, just so it makes it easier to see. So to stick it all over 9, get rid of that little thing there, there we go. So that's all over 9. If I flip it, it's just going to become 9 over 4 pi times h. Sorry, that should be h squared, shouldn't it? When I differentiate h cubed, that should become h squared. Yeah, sorry about that. I think I've just lost a squared there. So basically, if I just differentiate v with respect to h, it should just become 4 pi, so basically the h cubed becomes 3h squared, basically. So that's where the h squared comes from, okay? And what is dv? So then I just need to multiply that. So dh by dt is equal to dh by dt is just equal to dh by dv multiplied by the dv by dt. Well, dv by dt is just negative 0.01. I'm told that in the question. Then I just need to basically play with that to show that I can get to there, okay? So I guess I'm going to convert this 0.01, so I'm going to stick the negative out the front, and I'm going to convert that 0.01 into 1 over 100, okay? And then I could just multiply that 4 by that 100. So let's have a go. So I've got negative 9 over 400 effectively, pi h squared, okay? That's dh by dt. And then look, they just put the h squared over the other side. So let's just multiply through by h squared. So I've got h squared dh by dt is equal to negative 9 over 400 pi. That's what I wanted to show. Now, you've just got to be very, very careful here, because if you look up here, some people will just look at that and just try and immediately differentiate v with respect to h. Don't do that, because you've still got an r going on. You basically, the only way you can differentiate one variable with respect to another is if you've only got those two variables going on. If there's another variable snuck in there, you need to try and get rid of that other variable. And the key was there to just use similar shapes, okay?